Alrighty, I think we'll get started. Good afternoon, everyone. Thank you for joining today's NGINX workshop targeted for Department of Energy, NASA, and Department of Interior personnel. I'm Nick Strader with One Technology. I'm our federal practice leader. One Technology is an F5 NGINX small business partner. We're focused on data center and application modernization as well as cloud enablement. So for today, I'll briefly run through a quick agenda, followed by a few housekeeping items. Then I'll hand it off to Jesse Goodyear, who's going to be running the workshop from the NGINX F5 team. So our first hour is going to be dedicated towards an NGINX overview and an introduction of some of the technologies you're going to run across during this workshop. Second hour will be a demo of the lab environment and architecture. And then right around 2:30, we'll start that hands-on lab experience, allow you guys to get down and dirty on the technology itself. And in terms of housekeeping items, we'll have all the lines muted so you can take advantage of the chat feature if you have any questions. And we also have a breakout room for more in-depth sidebar conversations, so take advantage of that as well. And if there are any topics that we don't hit on today, feel free to let us know. Myself, the One Tech team, and the NGINX F5 team will gladly take time to set up additional hands-on sessions for you and your teams. And also today's session will be recorded. We'll send out the link afterwards. And we want to thank everyone for taking time out of your busy day to participate in the workshop. We hope you find value in today's session. And without further ado, I'll hand it off to Jesse Goodyear, who's going to be leading the workshop from the NGINX team. Take it away, Jesse.
Matt. Appreciate it. So, as Matt said, my name is Jesse Goodyear. I'm a solutions architect at NGINX, and really appreciate everyone joining. We also are able to offer everyone a 1-year developer license for NGINX Plus. So everything that you do during the hands-on workshop, you'd actually be able to replicate in your own environments and, customize for your own projects. So we will include that in the follow-up email after today. And if you don't see it, feel free to pester Matt and he will get it from me. One other quick add I had to the agenda, mostly because I just completed my some code for it last week, is a CDN demo. So just show you what the benefits of caching are. Very popular use case for using NGINX Plus, and kind of highlights some other things you can do. So with that, let's kick it off. I don't like to assume anyone has background with NGINX, so we do 5-10 minutes of just kind of history here. It's been around a while, but it's not Apache, right? So there was the internet, as it were, in the 90s changed a lot, and NGINX came out to solve a problem. Our founder worked for an internet company that did a lot of Yahoo type stuff, and browsers were getting really smart at opening a lot of concurrent connections in order to give their end users better user experiences. And the web servers that were trying to respond to those requests wouldn't keep up, and you'd have to add more and more hardware to address that. So NGINX is really modern code written to address the C10K problem, which is NGINX was the first thing to be able to handle 10,000 concurrent connections, which is C is concurrent, K is thousands. So fast forward a couple years through the 2000s, more and more, well, even until today, the internet's, obviously just taking off still. But the adoption of NGINX ramped up. I think actually my next slide shows kind of the history of, web server traffic. Initially, that's what NGINX was a kind of a proxy to files on disk, if you will. We now a proxy for pretty much everything out there, whether it's TCP, HTTP, HTTPS, lots of examples out there. But NGINX is the green line. We finally took over #1 web server market share back in 2017, 2018 timeframe. I think that the only reason I really show this is because it shows how much NGINX is trusted, how well the architecture's done in the past several years, right? This adoption of free open source NGINX for the most part is purely due to it just being a better architecture to solve a lot of problems. All right, so let me go back. 2011, the adoption was growing so much that customers were demanding support. So we founded a company around that. A couple of years later, our first product came out, which is NGINX Plus, which is the focus of most of today's talk and what you'll be getting hands-on with later. NGINX Plus being I meant to try my camera, so let me do that if anyone's interested in seeing me. So NGINX Plus is actually proprietary software, unlike things that other open source companies like Red Hat. They open source all of their solutions in some form or another. NGINX Plus is a proprietary binary built on top of NGINX open source. Gives a number of enterprise features that we'll get into in a minute. Fast forward again, NGINX Controller, which is a control plane for NGINX instances, which we creatively named. And that will give visibility into the performance of NGINX instances, as well as the ability to send configurations down to them, both via a GUI as well as through a declarative API that we expose. And then last year we were acquired by F5, almost exactly 12 months ago. And we are still committed to open source projects, and we're still committed to building new solutions in the market. So not a lot has changed. We're just under a new umbrella. And let's go on. Kind of put a picture to the portfolio here. NGINX Controller at the top, being the control plane for everything below it. NGINX Plus, as I mentioned earlier, gets to be known in the community as a web server, and then they quickly understand that there's a lot of functionality that works well because of its scalability and lightweight size, right? So it's a Linux binary, right? Runs on Ubuntu, CentOS, Red Hat Enterprise Linux, you name the flavor. We've just got a supported version for NGINX Plus. But it's about a 2 meg package. We can fit it on a floppy disk. Reality is when you start deploying the rest of the dependencies, it's probably about 100 meg Docker container, maybe a little bit less. But either way, a much smaller footprint than a lot of the solutions out there, including like a big IP virtual edition, which is about 10 gig. We'll get into where NGINX and F5 fit together in pretty much any architecture. And so if anyone's coming from a big IP background, we've got that for you today too. Most recent product announcement we've had actually, and my red arrow went away, so I'll just circle it with my mouse, is NGINX App Protect is the product name. It's a web application firewall, which is a module that we've created with the F5 Advanced WAF, intellectual property rule sets and threat campaigns that are behind that. And so it's sort of a lightweight version of Advanced WAF, if you're familiar with that. It certainly fits in a different portion of the architecture, and I've got pictures of that in a minute. So let's jump to that. Okay, so NGINX Plus being this proprietary solution, let's talk about why you would want that over open source. There's many customers, both federal as well as big banks out there that want support, and that alone is good enough reason to get a subscription for NGINX Plus, right? All support comes with the software, and it's an annual subscription. There's a few different licensing models. I'm not going to go into them. This is a technical call. Generally, it's licensed per instance per year, but there's also models for gigabits of bandwidth per hour, and there's number of successful API requests per month, measured in the millions. that's another conversation, but just to let you know, there's always a solution for getting support. When it comes to actual features, though, the main ones that we've seen drive adoption of NGINX Plus are around additional visibility. And so in open source, there's about 10 metrics that can be reported up to your tool of choice, right? Whether that's just writing to a log file or sending to Elk Stack, which we'll look at later today, or Prometheus Grafana dashboards. You know, with NGINX Plus, you just get a lot more granularity into what's going on. Native support for JOT tokens, as well as OpenID Connect, so authenticating users coming to the app at the gateway, right? And so instead of implementing all this logic at the web server itself, you insert it upstream, and it's managed much more natively there. Another good one that we've seen a lot of adoption of is the service discovery using DNS. So if you can imagine, every time you're scaling your web application and you need more backend servers to handle the requests, you need to add a pool member into that load balancer. And there's a couple ways to do that with NGINX Plus that don't involve downtime. Right? We have an API that you can just insert a new member into, and it will just dynamically add. Or if you've got service discovery with DNS, you just update your DNS server. And NGINX Plus will query that DNS server at whatever interval you define. And that way you don't need to do any configuration changes when it's simply adding members to a pool or removing them. And I tend to try to use big IP terms, even though NGINX calls pool members upstreams and upstream groups. So we'll talk a little bit about the terminology later too. But when I say pool member, I mean a backend web app that needs to be scaled up. Okay, there's a bunch more features that are in Plus. I'm not going to go into that. It's not a product sales pitch. I'm just trying to give you an idea of where NGINX Plus is being used. If you go to Google and type in NGINX Plus, feature matrix, something along those lines, this will be the first link, and it'll go in much more detail than I am. All right, so I mentioned that we have a new solution that came out last May around web application firewall. This is the most exciting thing I've been a part of in terms of product launch in a number of years, and it is great reasons for this product, and people and the customers that have been asking for it, and now it's we're finally delivering on it. So what it is, so NGINX is already high performing, and the modules you add on top of NGINX just give it more functionality. One of those modules right now is NGINX App Protect, right? We're still going to be very high performing, low latency in terms of we're still protecting the app. We're adding as little latency into that protection as possible based on the rule sets that we're running, pushing out. Trying to bring, it's a shift left mentality. So if you think of shifting left being implementing security before the first line of code is written, being a possibility. So the security team, creates a JSON file with the rule set that they want the developers to push with every code that gets pushed out, and that is what NGINX App Protect can do. Right, so I'll show you an example of a code snippet in a little bit, but again, it's all about not waiting for the last minute to implement the security policy and being able to implement this in a CI/CD pipeline that is almost like security positive nature, where you delete every single firewall rule every time the application is deployed, and you recreate it to be exactly what it was defined by the security team at the time it was needed. And so there's a pretty good demo on that later. I got before and after, so you can see what it was like before it was protected and after it was protected, and then security dashboard on what's going on. So pretty cool stuff. And of course, it's supported by F5. So here's an example of kind of a pipeline that you would, create your policy. This is very basic JSON example. I think it's got 4 key pairs here. And that gets loaded into whatever source code manager you like. I know in the federal space, you're probably more of a GitLab shops because you can run it on-prem. But GitHub is commonly used, so it's in the slide. And then whatever the rest of the CI/CD toolchain is, obviously just takes this policy and implements it as security as code, right? You've heard of infrastructure as code. If not, I'll just kind of give you a high level, right? We're rolling out the load balancer along with the application, along with the business logic behind that app. Here's the kind of the architectural where you can put NGINX App Protect. Kind of in the bottom right is the most obvious fit where, you know, third-party WAFs are too large to be put into microservices today. App Protect being a 100 meg Docker container, really good fit in that space. And, you know, anywhere microservices are being deployed, I think it's the best thing going. Even upstream, you know, if you think about, you know, having a global organization, you know, you potentially have perimeter security being handled by your F5 big IP. And then as you get down to the end applications that your end users are accessing or potentially end consumers, if you think about the postal service, you know, they're being protected, this would be pushed down towards the end, or towards the code rather. All right. That's kind of wrapping up on App Protect. We'll get to a little more hands-on when we get to the lab. What I'm showing you now is kind of what most enterprises, government agencies have built up over time, right? There was a technical need for a solution in every one of these spaces, and some technology got adopted because potentially that was the best of breed solution at the time. And all this builds up for good reason, but there's a couple of downsides to having so many vendors in your application delivery stack, right? That is, you need to maintain both, you know, licenses as well as expertise on every one of these technology vendors' stacks. When there's changes to the application, what needs to be changed upstream in order to accommodate that? I think the security profile of this is much greater and much more difficult to maintain than what we at F5 simplify down to this, right? So this is kind of before and after. Before you saw, you know, slew of vendors that, you know, were brought in at various times for, like I said, probably good reasons, down to a very trusted, very easy to support stack, right? This is calling F5 for support and still getting the same functionality that you saw with the myriad of vendors earlier, with the exception of, I would say, the visibility and analytics tools, right? So F5, we do have great tools in the space, but we are not looking to necessarily replace your sysdig, your Datadog, your AppD, right? We're gonna feed our data into those tools, and we're not looking to replace them. At the same time, we have some native tools that developers and you know, the F5 admins like to use because it's purpose built for managing you know, application delivery stack. Okay, so let's talk a little bit about. Let me see, where are my slides? Yeah. Application design, and then I'll get into Kubernetes in a minute. So this says Kubernetes here, but let's just consider this. Where your code's running could be a monolithic application, could be your move to microservice applications. And this model here where we have big IP doing the heavy lifting at the perimeter, right? So we've got limited change control requests that need to go in here. Hopefully you're changing that, you know, daily or weekly at most, something like that. Whereas you're allowing the application teams to deploy application changes for the application they support. So I'm trying to come up with a DOE or NASA-based application example, but I'm not familiar with something that you're doing. So I'm just going to give a kind of a commercial application that we all use on a daily basis, or at least weekly basis, when you log into your bank account. All right, so you go to chase.com and you want to see your current balance. And so after you log in, there's a frame on that website, and it starts to create some spinning wheels where it's loading data in the back end in order to show you your current balance, your latest statements, potentially some offers for different credit cards that you might be interested in. And each one of those boxes is this microservice that a specific app team is responsible for in the back end. And so when the current balance team, just to make this, again, the simple example we all work with, wants to upgrade the security profile of that, or potentially make it faster because they found some bugs in the code, right? They can roll out those changes hourly with their CI/CD tools without impacting the big IP upstream. All of those policies potentially for securing east-west traffic also go along with that. So if you think about another reason for NGINX Plus having all those metrics is when something comes in through the front door, great, big IP reports it up to your Splunk security system. But once it's microservice A contacting microservice B, what's seeing it? Who's logging this east-west traffic that's going on? In our view, that's NGINX Plus, right? Whatever data out of those 100 variables you want to pick from, you want to send up to Splunk is available. We also have the ability to make it so that all this traffic is secured using TLS keys. We can make it so that it all has to be authenticated using JOT tokens. We can rate limit all these requests based on where the request is coming from or what the request is for. Loads and loads of options. I'll try to keep this high level, but also give you a feel for what's possible in terms of being able to push out your apps and secure them quickly in a very clean environment what we've got here. All right, so I'm going to get into API gateways and API management and talk about how these microservices are likely just servicing API calls from that main website, right? And so this customer here that logs in, this is not an API call. This is a browser request to the main website to log in. After that, the main web servers are then requesting all the data through the microservices to fill in the back end. All those things are API requests going on in the back end here. Excuse me, I've been talking all day, so my voice is getting tired. And the majority of requests going over the internet today are those machine-to-machine communications. Give you a couple different examples besides that on-prem app that we're just talking about in terms of a banking application. But you also have publicly accessible APIs. Maybe bring up the USPS, right? If they've got third-party postal companies that want to get rates for USPS, they've got a website that says, give me your dimensions, and then they query a service at USPS that says, what's the rates? And then they show it to the end user, like stamps.com, right? That's not USPS owned, as far as I know. It's third party, but they're still getting rates directly from USPS. Another decent example would be, besides the ones you're seeing on the screen for Google helping out Uber or Dropbox, is Marriott. They've got a bunch of hotels, potentially in Manhattan. I want to say close to the Statue of Liberty. So I zoom in on the map, and that's a Google map that's being called via an API on the Marriott.com website. Right? And so Google makes a lot of money on that. They want to secure it, and so they use an API gateway in order to authenticate and give visibility into how many requests are coming so they know how to bill their end customers. API management builds upon that gateway, right? And so what I was describing earlier is this gateway that's responsible for handling the requests, getting it to the upstream server, the microservice is handling that data, and then sending it back to the client. API management is about both defining the policies as well as giving visibility into what's going on. And so there's other solutions out there, and there's let me describe how NGINX's approach to API management is different than basically every other API management solution in the market. I'm gonna grab a glass of water. So on the left here, your traditional API management vendors, the control plane's in path with the data plane. These chain linked, they're linked together. And so every request that comes in has to be processed by the control plane to figure out all the policies, where it needs to get routed to, and then it hits the data plane in order to find the upstream microservice. And once again, return goes through the control plane and responds to the client. This generally adds 60 to 100 milliseconds of latency, depending on the rule set, depending on the tool, to each request. And when doing millions of requests, it slows down the client application. Our approach decouples, unlinks the control plane from the data plane. So the control plane is still responsible for all the policies, for all the configurations, all the versioning of all the APIs. But it's pushing down those configurations to each data plane, which is an NGINX Plus instance, that is then very quickly processing those requests, right? We've got some of the best C coders in the world. They've gotten every bit of efficiency as they possibly can out of looking at different headers and processing, whatever your business rule is, whether that's authentication, rate limiting, very quickly before then, if it's a loud request, finding the end service and routing it back to the client. So we're being selected as a preferred API management solution where the customer really cares about performance, they care about scalability, and they trust the NGINX platform because it's the most used architecture for this in the world. So I forgot to load my survey question. So I just gave you some anecdotes where people are with Kubernetes today. Love to know where you all are at. If anyone wants to chat and say if you're just starting out or if you got full Kubernetes clusters servicing production applications, we'd love to know. I'll give you some anecdotes from previous meetings I've done with OneTech actually, and that most people are just starting to learn to understand Kubernetes. And most government agencies that we've talked to, it's a project that's going on right now, potentially a couple of production apps. West Coast tend to see a lot more, if you look at just commercial space, Kubernetes in production, than in the Midwest, right? I think Midwest is a couple of years behind in terms of the technology curve. I don't always think that's a bad thing. I live in the Midwest, so that's my perspective. All right, so before we talk about what NGINX does for Kubernetes, let's talk about what Kubernetes is to begin with, because I don't like to assume you've got background with it, although I'm sure everyone's heard the term because it's the buzzword of the past couple of years. And so give you another example of what Kubernetes does. So it's a orchestration tool for containers, right, at a high level. Why would you need an orchestration tool for containers? If you think about a website that's really busy certain times and not so busy other times, and they're putting everything in the cloud's billing them per, virtual machine per hour. It makes sense to spin those things down when they're not needed to handle the load. And so if you go with retail, right? So Macy's on Black Friday wants loads and loads of pods to be spun up to handle that demand that they're probably getting on Thursday and Friday. But yesterday, they probably need a lot less servers to handle, the lesser requests they've got because they don't have a huge sale going on Black Friday. So the Kubernetes is a thing that looks at the requests coming in, sees this, utilization, spins up more pods based on, responses slowing down. As these pods get spun up, we need to be able to find them. Right, so if you think of that website as going for the current balances, and this is the microservice for current balances, let's say, and we add a new pod with a new port and IP combination, something needs to tell that API request, hey, there's a new member in that pool, let's find it. And that thing is an NGINX Kubernetes Ingress Controller, okay? And there's a few different flavors of a Kubernetes Ingress Controller that I'm going to talk about, all three based on NGINX, only two maintained by F5 the company. And the differences between the functionality, I'll get into a little bit, but high level, the NGINX Plus Ingress Controller is, as you might expect, a lot more visibility, a lot faster because we're using native binaries, and we have got regression testing against all of the integrations we've done, right? And so we can't vouch for what the community Ingress Controller does, right? That's maintained by the Kubernetes community and not NGINX and F5 the company. So this chart I'm showing you right now compares those three different flavors that are admittedly named very confusing, right? And so I will discuss that briefly. On the left here, we have, if you were just to deploy Kubernetes cluster, it comes with an Ingress Controller. It's based on the NGINX Kubernetes Community Edition, right? And that's what it will look like if you go to GitHub. On the right-hand side, we've got the NGINX open source Ingress Controller, NGINX Plus Ingress Controller. Right, so NGINX open source actually has a few more features than even the community edition, and then the NGINX Plus has additional features built on top of that. All of that's described here. The slides will be made available to all you all. All of our Ingress information is on GitHub. You can see it's NGINX Inc. Anything you see under this repository, it is very well documented, heavily used. I mean, this Ingress Controller gets cloned, thousands of times a day. It's got some great examples for anyone that's trying to learn how to use Kubernetes, trying to figure out how to use Ingress controllers. Just to give you another idea what an Ingress Controller does, let me go back to the picture. And so these could be, I've been talking about kind of the same service running in this cluster and just different microservices on here, but this could be totally separate applications, right? So you could have www.nasa.com or gov, whatever your domain name is, going to one set of pods, and the Ingress Controller is looking at that header, right? In this case, we're talking about the host name, and it's routing based on that. Another request may be for /app1, and it's routing to that. So all kinds of layer 7 logic that we can use in order to route the application to the correct service and the correct pods. Okay, I'm going to take a quick detour from the workshop to show you a demo. And I'm going to exit out of my full screen. So think about, we're going to compartmentalize everything we just talked about. And now we're going to look at kind of NGINX in action. First one being this CDN demo that I recently built and would love to show you guys. So let me get the browser window up for you. Excellent. All right. And then there we go here. So if everyone's familiar with the browser tools, you press F12, or on a lot of computers, function F12 because we had the function rows. And in this side, I've got the network tab selected, and I've got disable cache selected. And so this is a caching example. And right now we're on a website that's hosted in Singapore. Just did that to make it a long way away from Michigan, where I live. And we're going to hit refresh with cache disabled and show how quickly this loads. I did take these pictures, so they're not licensed by anyone. I'm not stealing any content out there. They're all in Hawaii when I went last year. And when this finishes, you can see it took 10.2 seconds to load, which is actually pretty good. Now, browser cache works great. If I were to do a refresh, it would load instantly. You can see it's 1.2 seconds. Everything loaded super fast. But lots of applications can't depend on having already downloaded all this stuff into cache. And geography makes for latency. So the farther away something is, the more time it takes to do a round trip over the internet to get that data. And so I put a caching point in Ohio, in this case on AWS. Just to make it easy, the URLs are up here. And by the way, all this code is in GitHub. This site is open to the public. Very easy to deploy, especially when you get your developer keys. You just copy the keys into this GitHub repository that you've cloned, and you can deploy all of this on your own system. You just need to change the domain name. So anyway, we came to Ohio, and we can see that it loaded in half the time, a little under half the time. And if you think about most applications and how many thousands of requests, or at least a typical web application's got about 1,000 different objects that need to be loaded in order to display the web page. This one's got a limited number. I mean, you can fit it in, half a page here on a 1080 resolution screen. And so, very simple website, just designed to show you on this few round trips how much faster it is to do with some sort of caching between. We cache things like JPEGs and PNG images, but we can also cache code, whether it's JavaScript modules, CSS. And the more we do, the more, the faster it'll be for the end users. NGINX Plus also has an API available to manage the caching that's going on. And so let me make this bigger. This is the GitHub repository. So it's a Docker caching example. All this can be done in a couple Docker containers, very small. And then the documentation here shows you the API requests that we can do in order to clear out the cache, in order to do another test. I'm not going to do that. I think you get the point. If anyone wants to try it out, I'm happy to show you in the future. So that's just a quick demo. And then, of course, if you just want to go to aws-ohio.nginx.rocks, you can get to this anytime. Cool. So let's go to UDF. Dominic, how would it go provisioning everyone for UDF? And
so it looks like we've got, I think we're missing one person right now. The problem is I'm not sure who it is because UDF doesn't tell me exactly the email addresses. It just tells me people's names.
Okay.
So there's no way for me to cross-check. So I think we're gonna have to just go through and make sure everybody has a login.
Okay, so perfect. With that, I will say you should have received an email from udf@f5.com in the past hour. And there will be a temporary password in that. And when you create an account, it will be a permanent account on that UDF system. And so if you come to another workshop in the future, we'll just use that same username and password that you create this time around. We can always recreate that. If you lose it, just let you know that's an account you're creating on the F5 system. So when you get that, and I'm going to do like an incognito window or something. So if you go to udf.f5.com and you're going to click on non-F5 users. So we use this internally with our employees to do training. And so that's why non-F5 exists. And then you just log in with your username and password. And I've got a Jesse at home, but in general, hey Dominic, you want to try logging in, making sure you're not getting this 405. That's I forgot to pray to the demo gods earlier, so I'm gonna move on, but we'll hopefully fix that. Don't need to log in yet. Okay, so I'm gonna show you a demo of what you'll be doing once you do log into this hands-on environment. I'm also going to try to give you a complete enough demonstration here where if you don't have the time to do the hands-on, hopefully you get some value out of this. And I will say, if you don't get around to doing it today and you want to do it in the future, we can easily sign you up again. Tell us the time and day. We will make an appointment for you in the system and you can log in. The lab guide is publicly available. Anytime you want to do this, just open up the lab guide and it will walk you through the steps of this demo. So let me talk about the lab guide first. It's, again, publicly available on Read the Docs. You can even clone it on GitHub. So this is open sourced, if you will. And we're focused on this Arcadia Finance application. It's just meant to be a generic microservice application, very simple to understand. You know, it's not tailored to anyone specifically, it's fictional. And the instructions will walk you through everything that I'm saying. So I'm going to kind of go through just the high level stuff to make it so you can maybe whiz through a lot of this, but it's all written down here. And there's actual videos of one of our F5ers going through the actual steps as well. So very good documentation. And I give a lot of props to Matthew, the guy that did this. He's out of France and he's got very little accent. I hope you agree. Anyway, so this is the schema of the application. You can see it's a microservices design here where this is microservice 1, here's microservice 2, and so on, right? And so you can see the paths that are designated for each one of those microservices. And then the point of this particular workshop is to have specific WAF policies per microservice, right? And you can look at, hold on one sec. Okay, and Dominic says that UDF is doing well with just me. You can rate limit differently based on particular microservices that you want to be more secure or needs different security profiles. And so we're focused on WAF for this, but a lot of security principles, including logging and visibility, apply to everything we're talking about. The setup, and this is if you looked at what was on the invitation to this workshop, is we're actually going to deploy the application to Kubernetes. To do that, okay, the first few pages of the documentation are just kind of high-level instructions on what each step entails, and then when we finally get to doing the deployment, we'll talk about what's in that config file and what the command is that you're going to run, and on what service or on what virtual machine you need to run that command on. This is a YAML file, yet another markup language that has that Arcadia service defined in it. It's going to deploy this Docker container to Kubernetes, and it's going to run on port 80. And then the next step, we're going to look at the fact that it deployed those pods to the Kubernetes cluster within the Kubernetes dashboard. Here's the video, like I said earlier, of our friend Matthew discussing this demonstration he built. Very good overview when he runs through it. The next step, after you deploy the actual Docker containers that are responsible for running the application, is to tell the Ingress what it should do. In this case, we're going to route requests to kas.arcadiafinance.io to those services that we just created, right? And it's going to be based on these paths, right? So path files, path API, path app3. And this can all be modified. You can do SSL, you can do TLS, or but this is just meant to be a generic Kubernetes implementation of a microservice application, not real intense. Okay. Once we're done with that, we're also going to build a Docker container. This is the NGINX App Protect WAF that we're going to create policies for protecting this application. We're going to do some signature updates for that as well, just to give you a feel for what's entailed there. And then at the end, we get into deploying a custom error page via GitLab. So GitLab is part of this workshop, as well as being able to look at the progress of that deployment via Jenkins, as well as having different policies per microservice for the WAF. Altogether, if you're dedicated to going through the lab manual, copying and pasting pretty efficiently, you're probably looking at an hour and a half. But you can also get a feel for the first hour where you will get through deploying the application to Kubernetes. You will absolutely get through creating the Docker container for the NGINX App Protect, running through a couple tests of the WAF to see that it prevents malicious requests. and understand the functionality. Like the rest of the lab guide after that is to get into more details, including, I'll bring up the dashboard. Let's see, where am I? Let's go into the environment. So my screen's gonna look slightly different than yours, but for the most part, you should have all these tabs in the middle of the white section here. Just ignore this black section on the left. And importantly, lab guide will be here. You just open in a new window. Potentially, if you got a tablet, send it to that tablet so you can follow along. Although there's some copy paste, so you probably want the same computer. After that, take a look at the components, right? And so we've got a number of different virtual machines serving this environment. One is a Windows jump host. It's got Google Chrome available that shows the website, has bookmarks for all the tools that are used inside of the lab. And then we also have our Jenkins Terraform server. We've got a Docker server and GitLab, and of course the Kubernetes cluster itself. If you pay attention to the instructions, I think the first portion will be to log into the CI/CD server to deploy the application. You'll see this access underneath, and you do the drop down. And these are different services that we've exposed that are available. I would say it says to use SSH and not the web shell. Let's ignore that and let's actually use the web shell. It's much more straightforward than loading your public-private key into the system. So I'm just going to give a quick overview on how that works. So we're in a browser window, and then we make it bigger. We're logged in as root, but we actually want to be logged in as Ubuntu. And so I'll put this in the instructions for when we're done with this demo. But you do su Ubuntu, and it will log you in as Ubuntu. You do a CD, and you get to the home directory. Oops. Right. From there, you'll see that we have the files needed for the rest of the lab included here. One thing to note is that when you do a copy and paste, if you're on Windows, you need to hold Control-Shift-V in order to get the text to copy paste. I will also put a link, or put that in the instructions for when we're done with this demo. And also Control-Shift-C to cancel the command if you get in that situation. So that's just the biggest glitch is with the web shell. You have to press Control-Shift-V in order to paste. Otherwise, just highlighting the text will let you copy, right? So you can see they did a cut. All right, moving on. I'm going to access that, let's see, Windows jump host. To do that, depending on how many screens you have, I'm going to recommend modifying the resolution of it. So when you do this RDP, it should download a file. It goes to your downloads folder. I'm going to edit it. So when I do that, first of all, the username and password to this one are user, both username and the password. And then I'm going to change my resolution to something smaller than my screen so that I can switch back and forth quickly. Because I'm doing a demo for you guys, I'm going to leave it full screen so you can see more easily. Let's make it snappier too. Need a couple warnings, just ignore. Okay, so you'll be logged in to a blank desktop that looks like this. You'll see Chrome at the bottom. That's pretty much the only thing you need. And it will have a couple tabs that load automatically. And the username and passwords kind of fill in for themselves, right? So if you go to GitLab, I'm already signed in, but I'm going to sign out just so you see. Right, so the username and password built in the Chrome, you can just do that. Within this demo, what I want to show you first is that after you're done deploying Kubernetes files, it will create this website, right? So I've already deployed it because this does take some time, and I don't want to waste your time watching Kubernetes do its thing, watching Docker do its thing. So I've pre-staged this just to give you a feel for the lab. And you can see when we log in, we've got those microservice-based applications available. If we do a cross-site script here, where I was going to do a variable equal to this script, and you'll see that it worked. It didn't block anything, right? That was a good demo, all right, because we have not secured this application yet. The next step, after we deployed the NGINX App Protect Docker container, will be to hit that instead, right? And so if you were really rolling this out in production, you would change the URL to point to the WAF as opposed to the main website. In our case, we're exposing both so you can see the before and after very easily. And so you can see now we're pointed at the App Protect Docker container. We log in, we can still see that this application is the same, except for when we do that cross-site scripting exploit, it blocks the request. It gives us a support ID. The support ID is logged into the syslog that we sent up to. In this case, we're sending up to an ELK stack, which stands for Elastic, Logstash, and Kibana, all made by elastic.co. Anyway, we're looking at the Discover pane. When you log in initially, it's going to look like this. Hold on. Let's bring up a new one. Okay, it's going to look like that. First thing I recommend doing, down here on the bottom left, you can expand that and you can lock it. If you got a big screen like me, having this navigation on the left is not going to hurt you. What I did after that is click on Discovered. Excuse me. And we're looking at the last 15 minutes of data. I've got more from earlier, so I'm just going to go last 2 hours or something like that. And you can see I've got more stuff in the logs. And I was doing this search earlier on, okay, why did this request get blocked, right? So users are complaining, this WAF is blocking too much stuff. And now we, as the admins, need to figure out, well, what do we need to unblock from the WAF policy in order to allow that request to happen in the future? And so we have a support ID that we just copied from this web page, and then we can search for that. And it will tell us, oops, update, that it was a cross-site scripting exploit and what the request was going to and what the policy was that blocked it. So that's pretty straightforward. If you aren't familiar with ELK, we also open source all these dashboards that are available on GitHub. Anything I'm talking about that we don't follow up on, because I don't want to send you a million links to confuse everybody, let me know. Happy to send them to you. But if you search for NGINX App Protect, GitHub, you will find everything that we've got available, and there's some pretty good code available. Okay, so to kind of give you a little more visualization, again, it's the lab environment. We've only got 2 blocks here. Right there, the little red one. There was one earlier in time, but that's the one we just caused. And you can see what client did it, what the rule that the violated was, and dig into the rest of the statistics that we're bringing up to whatever your log system of choice is. This is an ELK stack, it's kind of common in the DevOps space, but again, whatever you like to use, we'll ship off to. With that, I'm going to stop, see if there's any questions. I will say at this point, feel free to log on to the UDF. If you have any questions, please hit the chat window. You can say all panelists, I believe, is an option for you all. We have the ability to do breakout rooms, so either Dominic or myself can help you with whatever the error that you're running into is. Could be that 405 thing you saw earlier, doesn't matter where it is, and I'll fix that. So Dominic, how's anything going in the chat, or are we good to go?
Looks good.
Awesome.
Yeah.
with that, I am going to minimize this. I'm going to edit this PowerPoint presentation to have the couple steps that I talked about available on the screen. And that's it. So thank you all for attending. Like I said, we'll follow up with you on all this content. And this workshop itself, the UEF, will be available for the next 11 hours, I want to say. And so if you can't do it this minute, it'll be available later. But Dominic and I will only be around for the next, we'll say, hour and a half, depending on how many questions we're getting. So again, thanks everyone. Appreciate you coming.